The hidden Biafran technologies. The war. They tried to hide in the shadowed halls of history. The story of Biafra's secret technologies has long been buried under decades of silence. While the world watched a devastating civil war unfold between 1967 and 1970, few knew that a small, determined group of engineers and scientists were quietly building weapons that defied expectations. These inventions, born of necessity, courage, and desperation, were not just tools of war, they were symbols of ingenuity under siege. Among them were the OGBU I and OGBU II, Biafra'S armored vehicles, and the legendary Red Devil machines, mechanized war devices that could challenge far superior forces. Hidden in makeshift laboratories across the eastern region, these creations were forged from scrap metal, salvaged engines, and sheer intellect. This chapter opens the door into a world that was never documented in history books. The engineers, many barely in their 20s, worked in secrecy, often risking imprisonment or death. Their goal was simple, yet monumental: to give Biafra a fighting chance against a better armed and more numerous adversary. Tonight, we uncover what the textbooks ignored, the inventions that might have changed history, and the minds behind Biafra's hidden technologies. The birth of OGBU I. As the war intensified, the need for armored mobility became urgent. The first response emerged from a small, dimly lit workshop in Umuahia, where a team of engineers, led by a young mechanical prodigy, sketched the outlines of what would become OGBU I. The vehicle was designed to navigate both dense forests and war-torn urban streets. Using parts scavenged from abandoned trucks, motorcycles, and local machinery, the team built a prototype capable of holding troops, delivering supplies, and withstanding small arms fire. Every weld, bolt, and reinforced plate told a story of resourcefulness. OGBU. I was more than a vehicle. It was a symbol of hope. Its creators worked silently, often sleeping in the workshop to maintain secrecy. Intelligence reports suggested Nigerian forces were unaware of the technological marvel hidden in Biafra's heart. The engineers named it OGBU, a term derived from local dialect meaning protector. Its mission mirrored the spirit of those who built it: to protect lives, assert resilience, and remind the world that innovation could rise from desperation. OGBU II, Evolution Under Fire. OGBU. I proved effective, but it had limitations. Enter OGBU II, an evolution of the original armored vehicle, incorporating lessons learned from the battlefield. Engineers reinforced the chassis, improved the engine, and even installed a rudimentary firing mechanism adapted from hunting rifles. The creation process was painstaking. Engineers had to modify engines to fit armored frames, balance weight to prevent tipping, and create an interior layout to maximize troop safety. Every obstacle required ingenuity. With no external funding, they relied on improvisation. OGBU II represented not just technical skill, but psychological warfare. Its existence alone boosted morale among soldiers and civilians. The armored vehicles became an unexpected legend, rumored to appear suddenly in battle and vanish without a trace. In secrecy, these machines were tested at night, in abandoned fields, with soldiers acting as testers. Each prototype carried the hopes of a nation fighting for survival, and each improvement was a testament to Biafra's ingenuity under pressure. The Red Devil machines. While the OGBU vehicles addressed mobility, Biafra faced another challenge: firepower. Enter the Red Devil machines, an experimental class of armored war vehicles designed to intimidate and counter heavy artillery. Constructed from steel scraps and salvaged engines, these machines had an imposing design that struck fear in enemies' hearts. Though never mass-produced, the Red Devils were tested in secret camps, with some reports claiming they could withstand multiple artillery strikes. The engineering behind them was advanced for its time, considering the lack of formal facilities and limited resources. Designs were passed secretly from one engineer to another, often under the cover of darkness. These vehicles were more than weapons. They were proof that necessity can drive remarkable innovation. Soldiers called them Red Devils for their fiery presence on the battlefield, and rumors of their capabilities spread faster than the war itself. Each machine carried the ingenuity of minds determined to redefine the art of war, despite overwhelming odds. The secret labs of Biafra behind every OGBU and Red Devil machine was a lab hidden from prying eyes. These weren't official military bases. They were garages, abandoned warehouses, and even private homes converted into research centers. Engineers used whatever they could find, scrap metal, old engines, discarded artillery, to build prototypes that could rival conventional military equipment. Security was paramount. Guards, coded messages, and night shifts ensured the projects remained secret. Many engineers lived in these labs, often going days without leaving. The labs became incubators of innovation, where desperation fused with genius. These hidden centers were also places of camaraderie. Despite the harsh conditions, engineers shared meals, ideas, and moments of levity. Their work wasn't just technological. It was human. They carried the weight of a nation's hopes, crafting machines that could change the outcome of a war that the world believed was already lost. In these labs, history was being written in silence, a silent revolution of technology and courage. The engineers who risked everything. Biafra's secret machines were not created by generals or politicians. They were crafted by young engineers, barely out of university, driven by patriotism and urgency. Many had never seen a real battlefield, yet their designs would influence the course of the war. Living in constant fear of raids, these engineers improvised. Steel plates were melted in backyard furnaces, engines salvaged from abandoned vehicles, and weapons modified from hunting rifles. Every prototype carried the essence of their ingenuity. The engineers understood that failure could mean death, not just for them, but for those relying on their creations. Many kept their work secret even from family, hiding blueprints in false walls or under floorboards. The stakes were immense, yet passion outweighed fear. It wasn't just engineering, it was survival. Their machines symbolized resilience and a refusal to surrender. They became the invisible guardians of a nation in peril, proving that brains could match bullets and creativity could rival conventional firepower. The first battle test of OGBU. After months of clandestine work, the first OGBU I prototype was ready for combat testing. Engineers and a small unit of soldiers chose an isolated field at night. The objective? Test maneuverability, durability, and troop capacity. As the vehicle rumbled forward, its metal frame groaned under weight, but it held firm. Engineers watched anxiously, noting weak points and balancing issues. Soldiers climbed in, firing rifles to simulate combat stress. To their relief, the OGBU I remained operational. Word of this miracle vehicle spread quietly among units. Morale surged. For a nation fighting against overwhelming odds, seeing their ingenuity in action inspired courage. The prototype's success proved that a determined few could create machines that challenged far superior forces. Though modest by modern standards, OGBU I's first test was more than a technical victory. It was psychological warfare, instilling hope where fear once dominated. Secret weapon innovation. Under siege Biafra faced constant bombardment and blockades. Yet while the world assumed starvation and defeat would end the war, secret innovation continued in hidden labs. Engineers devised machines capable of transporting supplies under heavy fire, while armored vehicles were reinforced to withstand artillery rounds. Constraints fueled creativity. Without industrial factories, every piece of metal was recycled, every engine salvaged. Designs were shared through word of mouth, with sketches burned after memorization to prevent capture. This secretive approach created a network of innovation that became legendary. Even intelligence officers from opposing forces were baffled, unable to locate the workshops. In Biafra, ingenuity became a weapon as lethal as bullets or cannons. The role of mechanics and artisans. The engineers were not alone. Skilled mechanics, welders, and local artisans became essential partners in the creation of OGBU and Red Devil machines. Their expertise in shaping metal, reinforcing engines, and improvising parts made theoretical designs functional. Many artisans had never built vehicles for war, yet their knowledge of local materials allowed them to fabricate wheels, tracks, and frames that could survive battlefield stress. Together, engineers and artisans formed a secret army of creators, blending skill and intellect in a way the enemy could not anticipate. This collaboration highlighted a key truth. In times of crisis, ordinary hands could produce extraordinary results. Biafra's hidden machines were a collective achievement, not just the work of a few geniuses. The OGBU II upgrade learning from battlefield experience, engineers modified OGBU II to address vulnerabilities discovered in OGBU I. The vehicle was lighter yet more armored, with reinforced suspension to carry more troops safely. Improvised firing mechanisms were added, capable of launching small-caliber rounds while protecting soldiers inside. Every improvement reflected lessons learned under fire, a remarkable feat given the absence of formal workshops or spare parts. The upgraded OGBU II became more than a vehicle. It was a symbol of adaptability, proof that innovation thrives even in extreme adversity. Soldiers called it the Ghost Protector, a testament to its sudden appearances on battlefields and the fear it struck in enemy lines. The Red Devil's first deployment. The Red Devil machines were shrouded in secrecy, but their first deployment would mark a turning point. Engineers selected a remote battlefield at the edge of the conflict zone for the initial operation. Soldiers were briefed in whispers, their excitement tempered by fear. The Red Devil rumbled into position under the cover of darkness, its steel frame gleaming faintly in moonlight. Though it lacked modern targeting systems, its mere presence intimidated the enemy. Rumors spread of a super vehicle capable of absorbing gunfire and delivering destruction, and these whispers traveled faster than official reports. Though the operation was small, it succeeded in demonstrating the Red Devil's resilience. Artillery rounds that would have destroyed ordinary vehicles barely scratched its armor. The soldiers inside felt a surge of confidence, realizing that ingenuity could level the playing field. The success of this first deployment sent a message to both sides. Biafra, though outnumbered, had a hidden technological edge. The Red Devil was more than a machine. It was a psychological weapon, a secret legacy of Biafra's ingenuity that the world had yet to understand. The secret of reinforced armor. Reinforced armor was the cornerstone of Biafra's secret machines. Engineers experimented with layered steel plates, welding techniques, and even concrete inserts to create vehicles that could survive artillery strikes. Each modification was painstaking, tested repeatedly under field conditions. Innovation was driven by necessity. With limited industrial support, the team had to improvise. Engines were reinforced to handle additional weight, and suspension systems were recalibrated for uneven terrain. Soldiers' feedback during tests informed every adjustment. The secret of this armor lay in its layered approach. No single plate bore the brunt of the attack. Instead, multiple materials absorbed and deflected impact. Enemy reconnaissance often failed to detect these modifications, giving Biafra an edge that few could quantify. This armor wasn't just technical, it was symbolic. Every strike it endured without failure told the story of resilience, creativity, and survival under unimaginable pressure. Engineers under fire. Many of Biafra's engineers experienced combat firsthand, not as soldiers, but as innovators under siege. Workshops were frequently threatened by enemy patrols, requiring rapid relocation or camouflage. Materials were stolen, blueprints destroyed, yet progress continued. Their work became a delicate balance between creation and survival. One misstep could cost lives or lead to the capture of critical technology. Yet, in these conditions, the engineers thrived. Each vehicle produced was a defiance against overwhelming odds, a testament to human ingenuity. Engineers learned to anticipate battlefield needs, incorporating mobility, armor, and weapon adaptations based on real-time intelligence. The machines were not static. They evolved alongside the war, responding to challenges that could not have been predicted in peaceful times. In these moments, the engineers became unsung heroes, crafting innovations that would change the course of Biafra's struggle and etch their names into a hidden history. The logistics of secret production. Producing secret war machines required more than engineering. It demanded ingenious logistics. Parts had to be smuggled through checkpoints, transported without drawing attention, and assembled without standard tools. Supply chains were improvised, often involving farmers, mechanics, and traders sympathetic to the cause. Workshops were decentralized to reduce risk, with each site focusing on specific components, engines, armor, or weapon systems. Coordination relied on messengers and coded signals, ensuring secrecy. Even mundane items like bolts or welding rods were carefully rationed. This intricate network allowed production to continue despite constant threats. Engineers, artisans, and support staff worked in shifts, maintaining secrecy while ensuring efficiency. The success of this system demonstrated Biafra's ingenuity not just in invention, but in the practical organization of scarce resources. The logistics of secret production became a silent backbone of Biafra's technological edge, proving that strategy extends far beyond the battlefield. The psychological impact of innovation. Beyond its physical capabilities, Biafra's hidden technologies had a profound psychological effect. Soldiers who rode OGBU and Red Devil machines gained confidence. Civilians drew hope from whispers of indestructible vehicles. Even enemy forces hesitated, wary of machines they had never seen before. Psychological warfare became an unintended consequence of innovation. Rumors exaggerated the machines' power, turning them into legends that spread faster than bullets. Engineers understood this effect, recognizing that technology could inspire fear or hope as effectively as a gun. The machines became symbols of resilience, representing a nation that refused to yield. Every successful test, every armored patrol, reinforced morale, proving that ingenuity could uplift spirit as much as it defended lives. In this way, Biafra's hidden technologies were more than weapons. They were a statement that even in the darkest hours, intelligence, courage, and creativity could shine brighter than the enemy's firepower. Innovation in isolation. Biafra's engineers worked in isolation, far from the front lines and foreign aid. Cut off from conventional industry, every design, prototype, and modification had to emerge from local resources. Engineers experimented with discarded engines, automobile parts, and scrap steel, learning through trial and error. Isolation forced creativity. Without blueprints or guidance, inventors improvised, transforming ordinary objects into sophisticated war devices. They adapted truck engines to power armored vehicles, welded steel sheets for armor, and even tested rudimentary suspension systems to withstand rough terrain. This environment fostered resilience. Failures were lessons. Successes became legends. Each machine carried the ingenuity of a people under siege, proving that isolation could fuel invention. By the end of 1968, the isolated workshops had produced a fleet of functional OGBU IIs and prototypes of Red Devil machines. These were not mere vehicles. They were embodiments of resourcefulness, courage, and an unwavering determination to survive against all odds. The Red Devil's secret weaponry. The Red Devil machines were designed not only for defense, but also for offense. Engineers mounted improvised firing systems capable of launching small-caliber rounds, Molotov-like incendiaries, and even makeshift rockets. Every mechanism was tested repeatedly under field conditions. Innovation was dangerous. Misfires could destroy the vehicle, injure operators, or reveal secret locations. Yet the team persevered, driven by urgency and national pride. Each successful test increased the machine's reputation as near-mythical war tools. The Red Devils became symbols of adaptability. Enemy reconnaissance reports mentioned unidentifiable armored vehicles appearing suddenly, delivering blows and vanishing, fueling fear and respect. These machines were proof that creativity could rival conventional military technology. Testing under fire field tests were crucial. Engineers brought their prototypes to secluded battlefields at night, simulating combat scenarios. Soldiers fired at the vehicles, testing armor durability and maneuverability. Every dent, spark, and malfunction provided valuable data. These exercises often involved risk. Enemy scouts or artillery could appear unexpectedly, forcing engineers to hide their creations quickly. Yet the tests were necessary, as Biafra could not afford theoretical designs. Every vehicle had to survive real combat conditions. By observing performance under fire, engineers refined OGBU II and Red Devil designs, improving protection, engine reliability, and firing mechanisms. Each test strengthened confidence among soldiers and civilians, proving the machines were more than experiments. They were practical solutions to existential threats. The engineers' code of secrecy was paramount. Engineers operated under strict protocols, with blueprints memorized and originals destroyed. Messages were coded, and only trusted personnel accessed sensitive information. This culture of secrecy ensured that enemy forces never discovered workshops or critical designs. Even within communities, knowledge was compartmentalized. No one knew the full scope of the projects. Families of engineers often remained unaware of the revolutionary work occurring behind closed doors. The code of secrecy became a discipline, instilling focus and urgency. It was a silent contract. Failure to conceal information could jeopardize lives, entire communities, and the nation's defense. In this environment, trust and precision were as vital as technical skill. Morale and national identity. Biafra's secret technologies were not just mechanical marvels. They were symbols of identity. Soldiers who rode OGBU IIs felt invincible. Civilians believed in the ingenuity of their nation, drawing hope from whispers of Red Devil machines. Innovation reinforced morale, showing that even under siege, Biafra could create advanced war machinery. These technologies became a source of pride, evidence that intellect and courage could challenge overwhelming odds. By integrating invention with national identity, Biafra's engineers contributed not only to military capability, but to the spirit of a people. Every armored vehicle, every improvised cannon, carried the weight of a nation refusing to disappear from history. The underground workshop network. To avoid detection, Biafra's engineers dispersed their operations across multiple hidden sites. No single workshop held all critical components. Engines were built in one location, armor reinforced in another, and weapons assembled elsewhere. This decentralization reduced risk. If one site was compromised, others continued production. Coded messages coordinated the movement of parts, while nighttime convoys transported completed components to central assembly points. The network's efficiency amazed even the engineers themselves. Despite resource scarcity, communication challenges, and constant danger, the workshops functioned as a seamless system. This invisible infrastructure was as critical as the machines it produced. It demonstrated a remarkable truth. Survival under siege requires not just ingenuity, but organization. The underground workshops were not only laboratories, they were the backbone of Biafra's technological resistance. Salvaging materials for survival. Materials for Biafra's secret machines were nearly impossible to acquire legally. Engineers relied on salvaging abandoned vehicles, dismantling trucks, repurposing engines, and even melting down local metal scraps. Every piece of metal, every engine component, had a purpose. Creativity transformed ordinary objects into extraordinary machinery. Truck frames became armored chassis, motorbike engines powered nimble vehicles, and metal sheets formed protective plating. This process required precision. Miscalculations could render a vehicle useless or dangerous, yet scarcity inspired innovation. The ability to improvise turned limitations into advantages, demonstrating that resourcefulness could rival conventional industry. Salvaging materials became a national effort, involving communities who risked lives to support engineers. Every successful build represented the unity and resilience of a people under siege. Night operations and field trials. Field trials were often conducted at night to avoid detection. Engineers and soldiers tested vehicles in secret fields, assessing durability, maneuverability, and firing mechanisms. The darkness added risk, but also realism. Soldiers simulated enemy fire, navigating rough terrain while vehicles endured mechanical stress. Every test provided insights, leading to adjustments in armor thickness, engine placement, and suspension balance. Night trials also instilled confidence. Soldiers learned to trust the vehicles in combat conditions, and engineers gained critical data to refine their designs. These covert operations blurred the line between experimentation and warfare, creating machines battle-ready from the first deployment. Adapting to battlefield challenges. The battlefield constantly evolved, and Biafra's engineers had to adapt. Mud, rain, uneven terrain, and enemy artillery posed unpredictable threats. Vehicles often got stuck, engines overheated, or armor buckled. Engineers responded quickly. Modifications were made in workshops, guided by first-hand reports from soldiers. Wheel designs were reinforced, engine cooling improved, and firing mechanisms adjusted for field reliability. This cycle of adaptation became a hallmark of Biafra's secret technologies. The machines evolved in real time, responding to combat pressures and environmental challenges. Each adaptation increased survivability, turning makeshift vehicles into formidable tools of resistance. The first operational squad. Once prototypes proved effective, Biafra formed the first operational squad equipped with OGBU IIs and Red Devil machines. Soldiers trained in stealth maneuvers, coordination, and rapid deployment. This squad became a mobile force multiplier. Their sudden appearances on battlefields disrupted enemy formations, boosted civilian morale, and tested the machines under real combat conditions. The operational squad symbolized the culmination of months of secret labor. Engineers' ingenuity had translated into practical battlefield effectiveness. Each mission reinforced the belief that intellect, creativity, and courage could defy numerical and technological superiority. Biafra's hidden machines had moved from concept to legend, quietly reshaping the narrative of the war. Engineering under pressure time was always the enemy. Each day brought new threats, enemy advances, blockades, and air raids, forcing engineers to work under intense pressure. Mistakes could cost lives, destroy prototypes, or expose secret locations. Despite these dangers, the team remained focused. They created detailed checklists, improvised tools, and often worked around the clock. Engineers learned to anticipate battlefield needs, prioritizing speed without sacrificing quality. Pressure also drove innovation. Designs that might have taken months in normal circumstances were completed in weeks. The urgency sharpened problem-solving skills, turning every setback into a stepping stone for improvement. Biafra's hidden machines were born not just from knowledge, but from the necessity to survive under relentless conditions, a testament to resilience and human ingenuity. Secret communications networks. Effective secrecy required more than hidden workshops. Engineers and coordinators relied on clandestine communication networks using coded messages, hand signals, and trusted messengers to transmit instructions between sites. Blueprints were never transported directly. They were memorized, reconstructed, and destroyed. Even a casual observation by enemy forces could compromise entire projects. These communication networks were as critical as the machines themselves. They allowed coordination across regions, ensured resources reached the right workshops, and protected the identities of engineers and artisans. Secrecy became a discipline. Every message, every transfer of components carried immense risk. Yet these networks ensured Biafra's technological efforts remained invisible to the outside world, a hidden force quietly shaping the war. The role of local communities played a crucial, often unrecognized role in sustaining Biafra's secret machines. Farmers, traders, and villagers risked punishment to supply raw materials, shelter engineers, or transport components. Local knowledge was invaluable. Certain roads, forests, and abandoned structures were identified as safe routes and workshops. Villagers understood how to avoid patrols and maintain secrecy. This collaboration created a network of support that extended beyond technical expertise. The machines were not just products of engineering. They were products of a community united in purpose. Every vehicle carried the efforts, courage, and ingenuity of countless unseen contributors. Engineering innovations. Inspired by necessity. Necessity is often called the mother of invention, and Biafra's engineers proved it. When conventional engines, artillery, or vehicles were unavailable, they adapted hunting rifles into mounted weapons, truck frames into armored hulls, and scrap metal into reinforced plating. Each innovation was tested rigorously. Adjustments were made to weight, balance, and firing mechanisms. Engineers learned to predict weaknesses and optimize designs for the unpredictable conditions of battle. These innovations were practical, effective, and often ahead of their time given the context. They transformed ordinary materials into war machines capable of challenging a larger, better-equipped enemy. Biafra's secret technologies were born of imagination, necessity, and relentless determination. Legends in the making. By late 1969, stories of the Red Devil and OGBU machines had spread quietly among soldiers and civilians. Rumors of invincible vehicles appeared in whispers, inspiring hope and fear in equal measure. The engineers' names remained largely unknown, yet their creations became living legends. Even enemy reconnaissance reports hinted at mysterious vehicles capable of extraordinary feats, creating a psychological edge for Biafra. These legends were not mere exaggerations. They were the result of countless hours of hidden labor, creativity under fire, and an unwavering belief that intellect could counter brute force. Biafra's secret machines had evolved from prototypes to symbols, a testament to the power of ingenuity, courage, and unity in the face of overwhelming adversity. Improvised weaponry. Biafra's engineers were forced to think beyond conventional designs. Lacking access to sophisticated artillery, they improvised weapons using whatever materials were available. Pipes became mortars. Engines powered mobile launchers, and modified rifles were mounted onto armored vehicles. Every creation was tested meticulously. Misfires were common, but each failure offered lessons. Over time, engineers refined designs to maximize reliability and impact. Improvised weaponry allowed Biafra to punch above its weight. The combination of ingenuity, experimentation, and resourcefulness made ordinary objects deadly, turning scarcity into strength. Soldiers grew to trust these weapons, knowing that every piece carried the imprint of human intelligence, creativity, and survival instinct. Covert manufacturing strategies. To avoid detection, Biafra's workshops employed covert manufacturing strategies. Vehicles were built in modular sections at separate locations, then assembled in secluded areas. Engines, armor, and weapons were tested individually before final integration. This approach minimized risk. If a workshop was discovered, only part of the project would be compromised, preserving the bulk of the production line. Transporting modular components required stealth and coordination, often under the cover of night. Covert strategies allowed engineers to maintain production despite enemy surveillance. These carefully orchestrated processes transformed ordinary garages and abandoned buildings into sophisticated factories, hidden in plain sight, ensuring Biafra's technological advantage remained intact. The Ghost Fleet. By early 1970, Biafra had assembled what soldiers quietly called the Ghost Fleet, a small but formidable collection of OGBU II and Red Devil machines. These vehicles moved quickly, striking unpredictably and disappearing before the enemy could mount an effective response. The fleet became a psychological weapon. Tales of their sudden appearances on battlefields spread rapidly, creating fear and uncertainty among opposing forces. Civilians, meanwhile, saw symbols of hope and resilience. The Ghost Fleet was proof that even a numerically inferior force could leverage technology and ingenuity to change the dynamics of war. It represented a hidden strength that few outside Biafra could fully comprehend. Overcoming resource scarcity. Engineers faced severe shortages of steel, engines, and fuel. Each day demanded creative solutions. Scraps from abandoned vehicles, industrial leftovers, and repurposed machinery became critical components for new machines. Fuel scarcity led to modifications in engine design. Lighter vehicles were built to conserve power, and some engines were adapted to burn alternative fuels. Every decision balanced effectiveness with sustainability. Resource scarcity forced innovation. Engineers learned to maximize efficiency, prioritize critical features, and make tough trade-offs. Their ability to overcome material limitations exemplified the ingenuity that defined Biafra's secret technologies. Morale on the front lines. The sight of OGBU and Red Devil machines had a profound impact on soldier morale. Infantry units reported feeling safer, more confident, and more willing to take strategic risks when supported by armored vehicles. These machines became symbols of hope, demonstrating that Biafra's ingenuity could counter numerical and technological superiority. Soldiers viewed them as protectors, guardians crafted from the minds of engineers who risked everything. Morale and technology intertwined, illustrating a crucial lesson. Innovation in warfare is as much about spirit and confidence as it is about physical capability. Biafra's hidden machines were a testament to human courage, intellect, and resilience under extreme adversity. Nighttime reconnaissance missions. Engineers and soldiers collaborated on nighttime reconnaissance missions to test the vehicles in real combat-like conditions. Under the cover of darkness, OGBU and Red Devil machines maneuvered through forests, riverbanks, and abandoned villages, evaluating mobility and stealth. These missions were dangerous. Enemy patrols and artillery threatened discovery, and any mechanical failure could be fatal. Yet soldiers reported increased confidence, knowing the machines were reliable, armored, and surprisingly agile. Night reconnaissance allowed engineers to refine suspension, weight distribution, and armor placement. Data gathered during these missions informed upgrades, making the vehicles more battle-ready with each sortie. The combination of intelligence, courage, and technical skill elevated the machines from prototypes to operational assets. The Red Devil mystique. Rumors of the Red Devil machines spread far beyond the battlefield. Soldiers spoke of armored vehicles that could deflect bullets, survive artillery strikes, and appear unexpectedly in enemy territory. The mystique served as a psychological weapon. Opposing forces feared ambushes, and tales of the Red Devil's invincibility inspired caution and hesitation in their operations. Meanwhile, civilians regarded the machines as symbols of resilience, fueling hope and belief in the nation's ingenuity. The mystique was intentional. Engineers understood that perception could be as powerful as firepower. By controlling information, they amplified the psychological impact of their inventions, turning technology into legend. Continuous innovation. Biafra's engineers never rested. Each deployment of OGBU and Red Devil machines revealed new challenges: terrain limitations, mechanical stress, or enemy tactics. Every setback prompted design revisions, from reinforced armor to improved engine efficiency. Collaboration between engineers, mechanics, and frontline soldiers ensured that real-world insights informed innovation. This cycle of continuous improvement allowed Biafra's secret machines to evolve rapidly, staying one step ahead of enemy adaptation. Continuous innovation demonstrated that ingenuity under pressure could transform adversity into a strategic advantage, redefining the potential of improvised technology in wartime conditions. Training soldiers in secret technology. Introducing soldiers to secret technologies required specialized training. Engineers instructed operators on vehicle mechanics, firing mechanisms, and maintenance procedures under covert conditions. Training emphasized stealth, coordination, and adaptability. Soldiers learned to navigate terrain, optimize vehicle performance, and execute surprise maneuvers while minimizing exposure. Knowledge of maintenance ensured machines remained operational even in remote areas. This combination of engineering and tactical training created highly effective units capable of leveraging Biafra's technological advantage to maximum effect, illustrating that innovation alone is insufficient without skilled operators. The hidden legacy. By 1970, Biafra's secret machines had left an indelible mark. Though the war ended in surrender, the ingenuity of engineers and artisans remained a testament to human creativity under extreme adversity. These machines represented more than military technology. They embodied resilience, resourcefulness, and the capacity to defy overwhelming odds. Every vehicle, prototype, and innovation carried the story of a people determined to protect their nation, culture, and identity. The hidden legacy of Biafra's technology continues to inspire, reminding the world that necessity, courage, and intellect can leave lasting marks, even in the shadows of history. Engineers as unsung heroes. The engineers behind Biafra's secret machines rarely received recognition. They were young, often in their 20s, and many never spoke of their contributions after the war. Yet their ingenuity shaped the conflict in profound ways. Working under extreme pressure, with scarce materials and constant threats, they produced armored vehicles and improvised weaponry capable of surprising larger, better-equipped forces. Their designs required technical skill, creativity, and resilience. These engineers were unsung heroes, operating in secrecy to protect both lives and a nation's hope. Each vehicle they produced carried the imprint of courage and intellect, ensuring that their legacy, though hidden, would endure in the stories of Biafra's resilience. The role of youth in innovation. Many of Biafra's engineers were barely out of school, yet their youth proved an asset. They approached problems with unconventional thinking, unbound by traditional military engineering norms. This youthful perspective fostered improvisation, allowing them to transform limited resources into functioning, effective vehicles and weapons. Their willingness to experiment, fail, and try again drove rapid technological advancements under wartime constraints. The involvement of young engineers highlights the importance of fresh thinking in crisis. Their creativity, energy, and risk-taking became the lifeblood of Biafra's secret technological achievements. Adapting civilian technology for war. Biafra's engineers excelled at adapting civilian technology for military purposes. Truck engines powered armored vehicles, motorcycles provided mobility for scouts, and agricultural machinery was repurposed for engineering tests. Every adaptation required careful calculation. Engineers balanced weight, durability, and functionality to ensure that civilian components could survive battlefield conditions. Improvisation transformed ordinary materials into extraordinary tools of survival. This strategy demonstrated ingenuity, turning scarcity into strength. It allowed Biafra to maximize available resources while maintaining operational secrecy, proving that necessity can drive innovation beyond conventional limits. The psychological edge. Beyond physical capability, Biafra's secret machines provided a psychological edge. Soldiers felt emboldened, and civilians found hope in their presence. Rumors of seemingly invincible vehicles spread, unsettling enemy forces. This edge was crucial. Fear and uncertainty among opponents reduced the effectiveness of their tactics, while morale within Biafra strengthened. Engineers and soldiers alike recognized that technology could influence perception, not just performance. The psychological impact reinforced the notion that innovation in war extends beyond engineering. Confidence, perception, and spirit are equally powerful tools. Legacy of resourcefulness. The story of Biafra's hidden machines exemplifies human resourcefulness. Engineers, artisans, and communities collaborated to overcome material shortages, technical limitations, and constant threats. Each vehicle, prototype, and modification was a product of creativity, courage, and collaboration. While history often highlights battles and political leaders, Biafra's technological legacy is a testament to ordinary people achieving extraordinary feats under extraordinary pressure. This legacy continues to inspire, reminding future generations that intelligence, determination, and innovation can redefine outcomes even in the most challenging circumstances. Engineers as unsung heroes. The engineers behind Biafra's secret machines rarely received recognition. They were young, often in their 20s, and many never spoke of their contributions after the war. Yet their ingenuity shaped the conflict in profound ways. Working under extreme pressure, with scarce materials and constant threats, they produced armored vehicles and improvised weaponry capable of surprising larger, better-equipped forces. Their designs required technical skill, creativity, and resilience. These engineers were unsung heroes, operating in secrecy to protect both lives and a nation's hope. Each vehicle they produced carried the imprint of courage and intellect, ensuring that their legacy, though hidden, would endure in the stories of Biafra's resilience. The role of youth in innovation. Many of Biafra's engineers were barely out of school, yet their youth proved an asset. They approached problems with unconventional thinking, unbound by traditional military engineering norms. This youthful perspective fostered improvisation, allowing them to transform limited resources into functioning, effective vehicles and weapons. Their willingness to experiment, fail, and try again drove rapid technological advancements under wartime constraints. The involvement of young engineers highlights the importance of fresh thinking in crisis. Their creativity, energy, and risk-taking became the lifeblood of Biafra's secret technological achievements. Adapting civilian technology for war. Biafra's engineers excelled at adapting civilian technology for military purposes. Truck engines powered armored vehicles, motorcycles provided mobility for scouts, and agricultural machinery was repurposed for engineering tests. Every adaptation required careful calculation. Engineers balanced weight, durability, and functionality to ensure that civilian components could survive battlefield conditions. Improvisation transformed ordinary materials into extraordinary tools of survival. This strategy demonstrated ingenuity, turning scarcity into strength. It allowed Biafra to maximize available resources while maintaining operational secrecy, proving that necessity can drive innovation beyond conventional limits. The psychological edge. Beyond physical capability, Biafra's secret machines provided a psychological edge. Soldiers felt emboldened, and civilians found hope in their presence. Rumors of seemingly invincible vehicles spread, unsettling enemy forces. This edge was crucial. Fear and uncertainty among opponents reduced the effectiveness of their tactics, while morale within Biafra strengthened. Engineers and soldiers alike recognized that technology could influence perception, not just performance. The psychological impact reinforced the notion that innovation in war extends beyond engineering. Confidence, perception, and spirit are equally powerful tools. Legacy of resourcefulness. The story of Biafra's hidden machines exemplifies human resourcefulness. Engineers, artisans, and communities collaborated to overcome material shortages, technical limitations, and constant threats. Each vehicle, prototype, and modification was a product of creativity, courage, and collaboration. While history often highlights battles and political leaders, Biafra's technological legacy is a testament to ordinary people achieving extraordinary feats under extraordinary pressure. This legacy continues to inspire, reminding future generations that intelligence, determination, and innovation can redefine outcomes even in the most challenging circumstances. Lessons in ingenuity. Biafra's secret machines taught enduring lessons about human ingenuity. Faced with scarcity, danger, and overwhelming odds, engineers created solutions that combined creativity with practicality. Every armored vehicle, improvised weapon, and Red Devil prototype reflected adaptive thinking. Challenges like material shortages, enemy advances, and environmental hazards forced rapid problem-solving. Successes were not accidental. They were the result of disciplined innovation under pressure. These lessons extend beyond war. They demonstrate how necessity drives invention, how collaboration amplifies talent, and how intellect can challenge brute force. Biafra's engineers showed that with resourcefulness and courage, even a small, beleaguered nation could produce remarkable technological feats. Engineers beyond the war. After the conflict, many engineers quietly returned to civilian life. Few spoke publicly of their work, yet their skills continued to shape industries and communities. Some applied their knowledge in manufacturing, transportation, and education, spreading the legacy of innovation beyond the battlefield. The war had created a generation of problem solvers capable of thinking creatively under pressure. Though their contributions were hidden from mainstream history, their impact endured. Biafra's secret machines were not just wartime artifacts, they were seeds of technological and intellectual growth for the future. Myth and reality. Over time, stories of Biafra's secret machines became mythologized. Tales of red devils surviving artillery, armored vehicles striking unseen, and engineers defying impossible odds circulated in whispers. While some details were exaggerated, the core reality remains extraordinary. These machines existed, they functioned, and they were built in secrecy under extreme adversity. The blending of myth and reality only highlights their psychological impact, showing how innovation can influence perception as much as performance. Biafra's secret technologies became symbols of resilience, ingenuity, and hope, a fusion of fact and legend that continues to captivate historians and storytellers alike. Preserving hidden history. Much of Biafra's technological history was deliberately obscured or forgotten. Workshops were destroyed, blueprints lost, and many engineers remained silent. Yet preserving this history is crucial to understanding the true scope of human ingenuity during the conflict. Documenting the story of OGBU I, OGBU II, and Red Devil machines honors the engineers, artisans, and communities who risked everything. It also serves as a reminder that innovation often occurs in shadows, away from recognition, under conditions where survival depends on creativity and courage. Biafra's hidden technologies are part of a larger narrative of human determination in the face of overwhelming adversity. the enduring legacy. Biafra's secret machines leave a lasting legacy. They demonstrate that intellect, resourcefulness, and courage can defy conventional limitations. The engineers' work, though hidden, reshaped the battlefield, inspired hope, and forged legends. Beyond military achievement, the legacy teaches the value of perseverance, collaboration, and innovative thinking. Even decades later, the story of OGBU I, OGBU II, and the Red Devil machines inspires historians, engineers, and creators to believe in the power of human ingenuity. The war ended, but the ingenuity it produced continues to echo. A timeless reminder that even in the darkest hours, the human mind can create wonders that endure far beyond conflict.